To determine the types of bonds, you need to look at the formula of the substance and take a look whether the elements in that formula are metals or nonmetals. To review, if you look at the periodic table, there is a line between the metals and the nonmetals, starting in the corner of boron, going down one and over, down and over, down and over, down and over. We call this the stair step. If it is a metal, it's going to be to the left of the stair step, and the nonmetals will be to the right of the stair step. The metalloids will be touching the stair step, with the exception of aluminum, which is a metal. Now, our one exception to the metal side here on the left is hydrogen, which is a nonmetal, even though it's on the left of the stair step line. Okay, if you have a formula that contains two of the same element, for instance, H2, O2, or I2, and nothing else with it, just two of the same element, these are all considered covalent bonds. These are a special type of covalent bonds called diatomic. Diatomic means literally two atoms. So if you have two of the same element, it's a diatomic covalent bond. Now, if you have two different elements, and they are both nonmetals, these are just regular covalent bonds. So if they are two different nonmetals, meaning they both come from the nonmetal side of the periodic table. In our first example, we have phosphorus and fluorine. Phosphorus is here, fluorine is here, both on the right side of our stair step, so both are nonmetals. Here we have selenium and chlorine. Selenium is here and chlorine is here. Again, both on the right side of our stair step. And then finally we have hydrogen and oxygen. You probably recognize this formula as water. Now you may think, wait a minute, hydrogen's on the left, but remember, hydrogen is our one nonmetal on the left side of the stair step, and it's bonded to oxygen, which is on the right side of the stair step. So hydrogen and oxygen is covalent. So if you have two different elements and they're both nonmetals, you have a covalent bond. If you have two different elements and one of them is nonmetal but the other one is metal, you have an ionic bond. So the metals are on the left side of our stair step. In each one of these examples, you have one element from the left side of the stair step, the metal section, and one from the right side of the stair step, the nonmetal section. First, we have strontium and nitrogen. Strontium is here on the left side, and nitrogen is here on the right side. So strontium and nitrogen is an ionic compound. Here we have sodium and chlorine. Sodium is here in group 1, chlorine is here in group 17, opposite sides of the periodic table, so we have an ionic compound. Here we have iron and oxygen. Iron is here in the transition metals. They are metals. They are to the left of the stair step. And oxygen is here on the nonmetals. So we have a metal and we have a nonmetal. We have an ionic compound. Sometimes you will have one metal with many nonmetal elements. A group of many nonmetal elements is called a polyatomic ion. And when you have one metal bonded with a polyatomic ion, you have also an ionic compound. So in this example, we have sodium, which is a metal, bonded with multiple nonmetal elements, which in this case, sulfur and oxygen. So that is an ionic compound. Here we have calcium, a metal, bonded with multiple nonmetal elements, oxygen and hydrogen. So we have an ionic compound. And then here we have zinc, a metal, bonded with multiple nonmetal elements, chlorine and oxygen. So we have an ionic compound. Now when you have multiple nonmetals together, these are called, again, polyatomic ions. They are a special type of ion, polyatomic ions. And anytime you have a polyatomic ion in a formula, you're going to have an ionic compound.